Hello students, and welcome back to another geometry video. You know what to do. Pause the video and try this problem in your notes, but before you do, there's one very important piece of information that I forgot to give you in the instructions, which is that trapezoid EHGF is similar to trapezoid JMLK. That is very important information. We cannot do this problem unless we know that these polygons are similar. So now that you know they're similar, pause the video, try the problem in your notes, then unpause it, and let's do it together. So, because these polygons are similar, we know that corresponding angles need to be congruent, and corresponding side lengths must be proportional. So, first thing I notice is angle Z, right? Angle E corresponds with angle J, so Z must be 65. 65. Now, some of you are like, isn't it 65 degrees? Well, Z already has the degree symbol there for you next to it, so Z is 65. Okay, cool. X and Y are both side lengths, so now we can move on to the side lengths. So, side X, which is KL, corresponds with side GF. Yeah, the one in between the two right angles. So GF is 11. And now we could put a proportion with y in it, or a ratio with y in it, but that's not helpful. I want only numbers so that I can solve for x. If I put a y in here, well, now I have two variables. How am I supposed to solve that? So just one variable for now. So we used x and 11. Now, let's see, EF and JK go together. So x goes with trapezoid, JMLK, and so does 20. So we're going to put those on top. Right, JMLK stays on the top. EHGF stays on the bottom. We're going to stay consistent with our ratios here. So 20 corresponds with, let's see, JK corresponds with EF. So 20 corresponds with 8. Now we can cross multiply. 8x equals 20 times 11 is 220. Divide by 8 on both sides, and we get that x is 27.5. Seems a little weird to get a decimal, but we can check that later. Now let's set up a proportion with y. We can still use the 20 over 8. That's not, yeah, we can do that. And then y is in EFGH, and it corresponds to the non-straight side, or I'm sorry, it is straight, the non-horizontal or vertical side, which is 30. So now we can cross multiply again. 20y equals 8 times 30 is 240. Divide by 20. And we get that y is 12. Okay, wonderful. So we can check our answers by setting up a similarity statement, or a statement of proportionality among all of our corresponding sides. For the sake of time, I'm not going to do that. I leave that as an exercise to the viewer. So let's go ahead and move on to what we have for today. Today we're jumping into 8.2. We are done with 8.1 and we are starting 8.2. Proving, don't worry, in this video we're not going to talk about any explicit proofs. So don't let proving scare you. But we're going to prove triangle similarity by AA. So, we are aiming to learn what the AA, or angle-angle similarity theorem, is. And our success criteria, how will we know if we have learned what the AA similarity theorem is? Well, can you use it to show triangles are similar? That's what I mean when we say proving triangle similarity by AA. In this video, we're going to show that they're similar. Like in the end of last video, we showed that two shapes were not similar. But now we're going to use the AA similarity theorem to show that they are. So, AA similarity theorem. But before AA similarity theorem, we have to review what similar figures are. So, geometric figures that have the same shape. They must have the same shape. But not necessarily the same size. They could have the same size, they could have a different size. But they must have the same shape. Size doesn't matter. Must have the same shape. Now, here's something new and important. The angle-angle similarity theorem. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So, if angle A is congruent to angle D, and angle B is congruent to angle E, then these triangles are similar. No ifs, ands, or buts. Because, remember in section 5.2, we talked about a theorem called the third angles theorem, which said, if I know what two of the angles are, I can find the third pretty easily, right? If this is 110 and this is 30, I can take 180 minus 140 and easily find the other angle. So if I know that 110 is angle B, that means that angle E is 110 degrees. I should have degree symbols here. And if angle A is congruent to angle D, that means that angle D is 30 degrees. And hey, if I do the same math over here, 110 plus 30 is 140. Subtract that from 180. Wow, I get the same answer over here as I do from over there. Which means, if I know that two angles of one triangle are congruent to the other, I actually know that all three angles are congruent. Because if you give me two, I can find the third. They always add up to 180. So, if I know two angles, I really know that all of the angles are congruent. And remember, the angles are what give a shape its shape. We said that similar figures need to have the same shape, but not necessarily the same size. Angles control the shape. Sides control the size. So when we're talking about similar figures, they have to have the same shape, which means they have to have the same angles. If they have the same angles, they have the same shape, size doesn't matter. Size does not matter for similar figures. So, we don't even care about the sides, right? When we're talking about the AA similarity theorem, this only talks about angles. It doesn't mention sides at all. And it's because we don't need sides. If I know that the angles are congruent, I have the same shape. Size doesn't matter. So, if you know that two angles are congruent, you can find the third angle. You don't need to find the third angle, but you know that the shapes, the triangles, are similar. So let's see an example of this in action. And actually, we're going to see 3 examples of it in action. So, using the AA similarity theorem, determine whether the triangles are similar. If they are, Write a similarity statement. Explain our reasoning. Well, I see that angle D and angle G are both 90 degrees, so we already know angle D is congruent to angle G because all right angles are congruent, and I'll even write that. All right angles are congruent. Now, I don't, like, obviously angle C and angle H aren't congruent, but what is the measure of angle E? Could angle E be congruent to angle G? Let's figure out what is the measure of angle E. So I'm gonna take 26 plus 90 degrees, and I get, 26 plus 90 is 116 degrees. And then if I subtract that from 180, I get 64 degrees. So angle E is 64 degrees. Hey, angle H is 64 degrees. Now we know that angle E is congruent to angle H because they're both 64 degrees. Now, this is almost a proof. Like what we've written right here, this is almost a proof. I would say we need to add, how do you know that angle E is 64 degrees? By the triangle sum theorem. So you'd need to add that step in, I think, to make it a rigorous proof. But this is almost a proof right here as we've written it. And I'm sure that you could have written something very similar to this. So proofs aren't that bad. Proofs aren't that hard. But we're not writing a proof. We are saying, are the triangles similar? And what we've done here is we've said that we have two pairs of congruent angles. Two pairs of congruent angles, which means I can use the AA similarity theorem. So yes, they are similar by the AA similarity theorem. And putting things in parentheses like this, explaining how we know, right? It says explain your reasoning. That's what makes a proof, is just that you explained your reasoning. So you probably have written more proofs than you think you have. But yes, they are similar because of the AA similarity theorem. And don't forget, they wanted us to write a similarity statement. So we're gonna write triangle CDE. We'll go in order of the alphabet. Is similar to triangle which angle corresponds with C? K. So I need to say K. Which angle corresponds with D? G. So I need to say KGH. Remember, you have to go in order. Remember, C should correspond with K because they're both first. E should correspond with H because they're both last. That's very important. That is a key feature of similarity statements. Because if you, like, as a mathematician, I expect that if I'm reading your similarity statement, oh, I should know that D is congruent to H, or corresponding. D is corresponding to G, C is corresponding to K, and E is corresponding to H. I should know that right off the bat as a mathematician. Any mathematician should be able to read this and understand that. That's why it's so important that you write your similarity statement accurately. Let's check our answer. Determine if the triangles are similar. Because they are both right angles, D and G are congruent. By the triangle sum theorem, angle E, the measure of angle E is 64, so E and H are congruent. So the triangles are congruent by the AA similarity theorem. That's exactly what we said. So yay! Also, I'm going to move out of the way to show you the bottom of this slide here. You can use colored pencils to show congruent angles, and that could help you with writing your similarity statement. So, I'm going to write the green angles first. CH. and K. I'm going to write the red angles next, D and G, and then I'll write the blue angle. So if you are a color coder, there is no shame in that. I am also a color coder. It doesn't make you less smart because you have to draw the colors. No. I draw colors. I use colors all the time. So do whatever you need to do. Whatever helps you learn best, embrace it. Embrace the way that you learn best. Okay, so we said the same thing and we were right. Haha. Let's move on to our second example, which really has like 2 examples inside of it. So you're going to get to see 3 examples of using the AA similarity theorem. So, in this example, they're saying these triangles are similar. We need to show how. Show that the 2 triangles are similar. How? They're telling me, and in fact, I'm going to color code, like I told you. They're saying triangle ABE is similar to triangle ACD. Oops. ACD. Good enough. They're saying that the red triangle is congruent to the green triangle. Not congruent. Whoa, not congruent. Similar. They're saying that the red triangle is similar to the green triangle. We need to show that that is true. Why? How do we know that the red shape is similar to the green shape? Well, look at this. 52, 52. Right off the bat, I can see, angle ABE is congruent to angle ACD. So there's one congruent angle. If I can show another set of congruent angles, boom, we're done, right? If I can have 2 pairs of congruent angles, that is the AA similarity theorem, and then we're done. We know that the 2 triangles are similar if I have 2 pairs of congruent angles. So, looking at the red and the green triangle, can you find another angle that is congruent? Or 2 more angles that are congruent? We don't know. I don't know anything about angle D and angle E, but wait a minute. Do you notice how the top of the red triangle is at angle A, and the top of the green triangle is at angle A? That's the same angle. Both of these shapes, both of these triangles have angle A in them. They use angle A as the top of the triangle. So they share angle A. Remember back in chapter 5, in section 5.3, 5.5, 5.6, if we had 2 triangles that shared a side, we could automatically say, oh, they share that side. That side is congruent to itself. We can say the same thing here. This angle is congruent to itself. And if you're curious, that's the reflexive property of congruence, that anything is congruent to itself. I am congruent to myself by the reflexive property. So, there you have it. We have the angles that are 52 degrees, and we have angle A is congruent to itself. So, we have 2 pairs of angles, and we're done. But Mrs. Dodge, I don't know the measure of angle A. I don't know if it's 100 degrees. I don't know if it's 90 degrees. It doesn't matter. We don't need to know the measure of these angles. We did in the last example, we did. In this example, I can see that they're congruent. I can prove that angle A is congruent to itself without knowing what its measure is. Anything is congruent to itself. Doesn't matter how many degrees it is. Okay. All right. The next example, part B, is going to take us on a trip down memory lane. We're going to have to remember stuff from chapter 1. We're going to have to remember stuff from chapter 3. This is why it's important when we say, you're going to use this later, please remember it. We mean it. Okay, so triangle SVR is similar to triangle UVT. We need to show that this is true. Now, remember that when I have two lines, whoops, I want my black pen. When we have two lines that cross, we know that the angles opposite them are congruent. These are called, what type of angles are these? Can you remember? What type of angles are these? They are vertical angles. So we know angle SVR is congruent to angle UVT because they are vertical angles. They're vertical angles, and vertical angles are congruent. That was a theorem that we learned about in chapter 1. So there's one pair. There's one pair of congruent angles. If I can find another, then we're done. So, obviously, somehow, one of these other pairs of angles are congruent. Notice, what are these red arrows that they put here? What do those red arrows mean? Remember, these red arrows mean parallel. Ooh, if they gave us that information, if they told us that these lines are parallel, we can use that in some way. And we need to use that in some way. So if you see red arrows, don't ignore them. Think, oh wait, red arrows mean that the sides are parallel. What can I do? What do I know about parallel sides or parallel lines? So, I'm gonna extend. These sides being parallel means that the lines that contain the sides are parallel. So I'm gonna extend these sides for the sake of seeing something. If I extend these lines, then I'm gonna extend line SVU. And in fact, actually, I kind of want to do this in a different color because this is getting messy. Well, let me redraw this over here. I have S, I have R, I have T, and I have U. And I am drawing, and then I have side SU going through the middle of it. And these are parallel. We know that these are parallel, so let me draw these red arrows in here. These sides are parallel. Well, hey, what do I know about these angles? What kind of angles are these? Remember, SU, line SU right here, this is a transversal, right? I have two parallel lines, and I have a third line intersecting them both. That is a transversal. Think back to chapter 3, section 3.1, when we first started talking about transversals. And I guess this is actually section 3.2, because if I have parallel lines, then alternate interior angles are congruent. So, angle RSV and angle TUV are congruent. It's hard to see it without extending these lines, like extending the sides of the triangle. But anytime you have parallel lines, look for alternate interior angles, alternate exterior angles, corresponding angles, something like that. Okay, so now we know that angle RSU is congruent to, to make this a little bit shorter, let's see, RSU means TUS, angle TUS. Because they are alternate interior angles. And we have one pair of congruent angles, two pairs of congruent angles, so we're done. If I have two pairs of congruent angles, it means that the triangles are similar by the AA similarity theorem. And this is true for both A and B. I showed that two pairs of angles were congruent by the AA similarity theorem. These triangles are similar. Let's see if we were correct. Angle A is congruent to angle A by the reflexive property. Vertical angles congruence theorem. And then side RS is parallel to UT. So angle S is equal to angle U by the alternate interior angles theorem. Now, some of you are wondering, could I have used these? Couldn't I have extended side RT and gotten the same result? Yes. Yes, you could have. We chose to use the other transversal, but you easily could have used the other one. Yeah. Okay, cool. We were correct. Now is a great time to assess your understanding of the learning target and the success criteria. So, do you know what the AA similarity theorem says? Do you know what it means? If what, then what? Do you understand what that means? I need to have this if part. If two pairs of angles are congruent within two triangles, I need to have that, and then I know that the two triangles are similar. Do you understand what it means? And can you use it? Can you show if two triangles are similar using this theorem? If you do, woohoo! Finish your homework, help your friends with their homework, help your classmates. If you're a little iffy, that's okay. Start on the homework, ask for help if you need to, and if you are not vibing with this lesson, that's okay. There are all things that we don't vibe with. We just need to ask for a little bit of extra help. So definitely ask questions if you need to. Here are some practice problems you can do to practice the skills that you have learned in this video. First are like example 1, and the second set is like example 2. Let's end our video with a launch from Ray LeBlond. And he says, you learn something every day if you pay attention. Now, is this the teacher trying to say, yeah, see, you need to pay attention to me? No, that's not what I'm saying. That's not what I'm saying at all. And this doesn't necessarily even have to apply to math or like a school subject. You can learn something new if you pay attention to your friends. How they act. Are they acting differently today? Oh, when he gets upset, he does this. Oh, you can notice things. You can learn something new every day if you pay attention. So what is it that you want to pay attention to? What is it that you want to learn? Do you want to learn more math? Pay attention to math. Do you want to learn more about how people interact with each other, how people react to different things? Pay attention to people and how they react. What is it that you want to learn about? That is what you want to pay attention to. Obviously, pay attention in your classes because, you know, you got to jump through the hoops that are school so you can be successful. So learn, pay attention so that you can jump through those hoops. But do what you want with the knowledge that you get from jumping through those hoops. But what do you want to learn? That's what you need to pay attention to. So what do you need to be paying attention to today? That is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day. And thanks for being here. Thanks for watching. Bye.